think that all through, of course, the tiger would eat me, right? So the body brain actually was built to, you see the tiger through your eyes, it comes into the amygdala and gets your body going. You don't even think about it. It's, I see the tiger, I've got to run. And there's no other thinking process that's involved in that, because it's going to keep you safe. It's kind of like when a mom sees their kid underneath the car and without thinking lifts the car and gets their child out of harm's way. And then afterward, you know, she thinks, God, how did I just do that? That was body brain. That was body brain putting enough adrenaline into her muscles to be able to lift that car and do that thing that she needed to do to get her child safe. The mammalian brain, or I like to call it feely brain, is in the middle there. It's surrounded by the yellow piece there, that's called the corpus callosum, and then the blue stuff. And that is both the limbic system, where our emotions are processed, and that's our rewards pathway as well. And we know that because when we can put people in brain scans and we can trigger them into, say, like a drug craving. We understand now what part of the brain gets activated when someone is triggered to, say, use a drug. Or we can prompt an emotional response to somebody and then see where the brain lights up in a scan. And we know that it's right there in the middle of the brain. And we call it mammalian brain because mammals have it. Reptiles don't have it, but mammals have it. And you know, and we might generally agree that mammals can feel things, and mammals can have, actually, animals of prey do not get PTSD because they run, and if they do get away, you know, they do their fleeing, and if they do get away, if you've ever seen like a rabbit after being chased, they'll get real still, and then they will just sort of tremble and sort of like ripple, their skin will sort of like ripple through it, and they're releasing all of the energy, all of the physiological energy that was created in the process of fleeing, and then they go about their business. And then they hop away merrily along and do their thing. Well, if you've seen The Horse Whisperer, we know that mammals most certainly can have PTSD. Certainly, I was just reading a book about military working dogs and how they can develop symptoms of PTSD, and it really makes a lot of sense. And we know we know it's happening in that part of the brain. So that's why I like to call that feely brain, because that's where all our feelings are. And then prefrontal cortex, or the thinky brain, and that's that gray stuff, the cortex, just in front of the limbic system there. And actually, I'll just kind of, I can use my little thing here. So it's like this piece here, and it sits right behind the forehead. And it's the last piece, only humans have it, and it's the last part of our brains that develop. And we actually don't develop until about, it's not fully developed until about 25. So, and that is our executive functioning. That's what allows us to do all the things that make us great as humans. You know, think and answer the complex questions, and make decisions, and do really hard math problems, and again, all those things that make us great. Really hard math problems. Whoop. There we go. Okay, and then this is again the same orientation, where it would be the head split down the middle. You've got a big piece of the prefrontal cortex behind the brain, the forehead. The red part there that's called the amygdala, that's our fire alarm. That takes all the sensory data that comes in through ears, eyes, touch, and filters it for danger. It right behind it there in the next picture is the hippocampus, and that's our memory bank. As you can see, it's connected right, it's touching the hippocampus, or the amygdala. So amygdala catches the sensory data, filters it through, checks with hippocampus to see what kind of data regarding that sensory information has been stored about it. And has any of that been related to danger? And of course, it happens in split seconds, which is why when we see the kid under the car, we lift the car up without thinking, or we run away from the tiger without thinking, because it happens just that quickly. And for folks that have trauma, their amygdala is necessarily a hair trigger, because you've got to know what keeps you safe, and you've got to know what is dangerous. Sometimes the perception of what is dangerous is really amped up, and that's where I think sometimes we can see conflicts in the shelter, because some kind of slight was misperceived, something that was not intentional was perceived as something intentional, and there's a broad overreaction, and that's all brain stuff. The brain is doing that for us automatically. Pardon me. Whoops. So the stress response. This is the physiology behind trauma and the traumatic stress response. If there is danger, and let's also say perceived danger, the brain will shuts off thinking. It just shuts it off, doesn't let it have contact, and takes the doing part of the brain to act. It makes that in charge, right? So you're not thinking about anything, you're just making your body, firing up the chemicals that you need to go. And it might be to fight, to protect yourself, it might be to flee, or it might be to shut down. And we see that sometimes as well as another kind of response. But it's a very sophisticated electromagnetic process that happens in the brain. It starts in the brain, and through the release of chemicals like cortisol, which you've probably heard from the belly fat medications, that cortisol, that stress hormone, starts to get flooded into the bloodstream. That moves our blood out of our guts and innards out to our limbs, and that allows us to run really fast or to, lift the car up. It also takes the blood away from the core, so that if we should get bitten or shot at or stabbed, we won't bleed out either. Also, it runs some endogenous opiates in our brain called endorphins, so that as I'm running away from the tiger and I should stub my toe, I won't go, oh crap, oh my gosh, that hurts, oh, oh, I'm going to lose my toenail, oh, because then again, of course, the tiger would get me. So you don't even feel that. In fact, you may have lost your toe entirely, and you're going to keep going until you get back safe in your cave, and you go, now all of a sudden you're going, ouch, my toe hurts, and go in there and say, whoa, half of it's missing. But you won't notice it until you're safe again. Your brain won't even give you access to it until you're safe again. And so that's body-brain really taking over for you. So well, let's nutshell it here, as it says. Trauma is pervasive, and we looked at the numbers. It affects people in multiple ways. And that looks like things like in their own relationships, their ability to regulate, to cope with their intense behaviors, intense emotions. And, if you're not going to cope, if you don't have any good skills to cope safely, then there's always the risky ones, the substance use, or maybe acting out sexually, or doing cutting, or overeating, or overspending, or overworking, or gambling. There's a number of ways we can get a nice dopamine rush that will help us feel better temporarily. So that's where the risky coping strategies then come in, and that may ring true and be familiar with people that you serve. So that means we as helpers are at risk of re-traumatizing clients based on how we operate in the context of our relationship. But when we become trauma-informed, we can facilitate healing. And that doesn't mean you have to be a therapist or you have to be trained to be a therapist at all. I'm talking even about shelter staff and how shelter staff operate during the course of their shift can help facilitate healing.